Friends, next question, deep learning. Enter question. In a time series prediction task using a GRU, gated recurrent unit. GRU means gated recurrent unit network. The GRU process input sequences where each input is represented by a two-dimensional vector xt belongs to R square. So this is the input, xt is the input vector and is belong to R square, that is in two-dimensional R2. So the dimension of xt is two-dimensional, 2 cross 1. The GRU, the gated recurrent unit, using the formulas, that t is the time step. So I of t in GRU, LSTM both are similar, except in LSTM doesn't have forget gate. In LSTM we have forget gate also. In GRU we don't have forget gate, update gate and reset gate. Two gates are available in GRU. Gated recurrent of t equal to sigmoid of WIT ST minus 1 UI XT plus BI. So BI is the input bias, XT is the input vector. This is XT is input vector, UA is, this is the weighted matrix. U, W, V are weighted matrices. These are. ST minus 1 is the hidden state of the previous state. T minus 1 is the, T is the time step, T minus 1 is the previous state, ST is hidden state. IT is the update gate. So update gate output. Why we use GRU? Required less number of gating signals compared to LSTM. LSTM is long short memory unit, and O of T is the reset gate output. This is also sigmoid function of the previous hidden state, and the input B0 is the bias values. ST tilde is a just parameter, dot is the element wise multiplication, the had mod product, dot. V into HT plus C is the output bias, C is the output bias. So here they gave a dimensions of the HD is R cube, three-dimensional vector y hat of t. Output of this complete GRU is R2 and XT input vector dimension is two-dimensional. So in this question, GRU process the sequence of length 6, that is time step t equal to 6. What are the total number of parameters including bias in the network? So mainly they are asking including bias, without including bias, to calculate the parameters of this network. In this network. So how to solve this? GRU applications. These are GRU applications used in sentiment analysis, time series forecasting, machine translation and speech recognition. In GRU, total number of parameters 3 times the n square plus nm plus n, where n and m are the dimensions of, n is the cell state dimension and m is the input signal dimensions. ST is a hidden state, n-dimensional hidden state. So how to solve from these equations? So I of t equal to HT equal to ST minus 1 equal to OT. That is the dimensions of the update vector IT, HT and the hidden state ST minus 1 and ST minus 1 both are same dimension, and output OT is also have the same dimensions. So they gave a HT of dimension 3. So that is equal to 3 dimension 3D R power 3 R3. So from this equation we calculate the parameters. So first I of t equals to IT equals to Wi from this equation, update equation, Wi ST minus 1. All these are matrices. So they gave IT equal to dimension R3, that is 3 cross 1. So Wi we don't know. ST minus 1 is also 3 cross 1. So because all these have the same dimension. So 3 cross 1, this is 3 cross 1. 3 cross 3. If it is Wi is 3 cross 3 only, we get 3 cross 1 I of t output. So W is 3 cross 3, 3 into 3, that equal to 9 parameters. 9 parameters. Next I of t equals to Ui into xt. Xt is input vector dimension 2D, that is 2 cross 1. So IT is 3 cross 1 dimension they gave. So U is 3 cross 2. Only if both the dimensions are same, that time only the matrix multiplication is possible. So U parameters of U equal to 3 cross 2, that equal to 6, and the bias BI. So including bias, they are asking including bias also. So add bias BI. So BI is also a dimension of the same IT dimension, that is 3 cross 1. So bias B has a parameters 3 cross 1, that equal to 3 parameters. So total 18. Total 18 parameters. Next coming to output parameters. So the output equation y hat equal to VHT plus C. We have to find the V parameters of V and the C size. C and V. So from this y hat equal to V times HT. They gave YT 2 dimensional 2 cross 1. HT is 3 dimensional 3 cross 1, and V is 2 cross 3. So the parameter V equal to 2 cross 3, that equal to 6. And C is same dimension of y hat t. So C equals to y hat t dimension same, that is 2 cross 1, that equals to 2. C parameters 2 into 1 equals to 2. So total 8. So this is for input equation I of t. Input equation for I of t is 18, and this is same parameters for Wi, W0, Ui, U0, B0, 2 and ST also. 3 equations. So you have to multiply 18 with 3. So 18 into 3, that equals to, because there are 3 equations, Wi, W0 are same parameters, that equals to 54. And output equation is only 8, only one equation, and 8 output equation only one equation. So add total parameters are 54 plus 8, that equals to 62, including bias. So the answer for this question is 62. Total number of parameters including bias. If there is no bias, you have to remove these three. If there is no bias, without bias, remove these three, that is 9 plus 6, 15 into 3 plus only 6 without bias. So without bias, this is the answer. With bias, total parameters 62. Friends, if you like this, please subscribe my channel.